Good evening, children.
Good evening, ma'am.
Good evening, ma'am. Good evening, children.
Good evening.
Good evening. All right, children, let's solve some numericals from circles. Look at this question. If SQL, if angle SQL, if this angle, if angle SQL is 50 degrees and SRM. Oh, before this, children, I need to introduce one theorem to you. Okay, just a second. You don't have to worry about the derivation of this theorem. You have to know how to apply this in a situation. So see here. Circle, chord, one endpoint of the chord, other endpoint of the chord. Through any one endpoint, we take a tangent. Through any one endpoint, we take a tangent. Circle, say with center O. Circle with center O. Am I clear, children? Audible and clear?
Yes, ma'am.
Yes,
Okay.
yes, ma'am.
So, all right, children. So circle with center O. Chord, let's name the chord AB. So A and B are the endpoints of the chord. Now, at this endpoint B, we'll take a tangent to the circle. What is a tangent? It's a line which touches the circle at exactly one point. So say that this tangent touches the circle at B. The tangent, this line, which is a tangent, touches the circle at B. So this is what is required to use the result of this theorem, which is called alternate segment theorem. Alternate segment theorem. Alternate segment theorem. Given a situation like this, we can find out some more results. Given certain information, we can get some more results using this theorem. We'll see what is to be given and what you can get out of this theorem. Okay, so the situation is circle with center O, chord AB. A and B are the endpoints of the chord. Through any endpoint, A or B will take a tangent. So there's a tangent touching the circle at B. Now this is the angle. This is the angle between the tangent and the chord. This is also an angle. See here, children. This is also an angle between the tangent and the chord. This is also an angle between the tangent and the chord. Okay, let me say that these two are the angles. I've marked the angles. I call the tangent PQ. Angle ABP and angle ABQ. Okay, are the two angles made by the chord with the tangent. Angle ABQ and APB. See that APB. It's the angle. Sorry, ABP. ABP. This is the angle between the chord and the tangent. ABP. Similarly, ABQ. See the angle ABQ. It's the angle between the chord and the tangent. Please make a note of this, children. I need to clear the slide. Give the heading alternate segment theorem. Are the angles, please write on this, made by the chord AB with the tangent PQ, with the tangent PQ. Please write on this. All right, can I clear the slide?
Yes, ma'am.
Okay. So let's take up the angles one by one. Let's take up the angles one by one. So first, let's talk about first let's talk about this angle ABP. Now you can see, you know that a chord divides a circle into two segments. Now here, this is the minor segment. This is the major segment. A chord divides a circle into two segments. Here, this is the minor segment, and the other one is called the major segment. Now, this angle between the chord and the tangent is in the minor segment. It's this angle. See this angle ABP. It crosses the minor segment. This angle crosses the minor segment. This is the minor segment. This angle between the chord and the tangent crosses the minor segment. See here, this is the minor segment. It crosses the minor segment. Now we have to find an angle made by the same chord in the alternate segment, that is in the major segment. We have to find an angle made by the same chord in the alternate segment, which is the major segment. Why major segment? Because this angle crosses the minor segment. So you have to find an angle in the major segment. For that, take a point on the circumference of the major segment. This is the major segment. The rest of it is the major segment. This one is the major segment. Take any point. Take any point on the circumference of the major segment. Join the ends of the chord. See, if you call this point, say R, join the ends of the chord. Join AR and BR. That is the end points of the chord ABR, A and B. Join A to R, B to R. And you can see an angle formed on the alternate segment. You can see an angle made by the chord in the alternate segment. You can see an angle made by the chord in the alternate segment. Now, according to this theorem, angle ABP is equal to angle ARB. I'll do it again for you. So we are relating two angles. One angle which crosses the minor segment, the other which is in the major segment, made by the same arc. Sorry, made by the same chord or with respect to the same chord. AB is the chord under consideration. AB, the chord AB and the tangent makes an angle here, which is called angle ABP. Angle ABP crosses the minor segment. We are trying to find an angle in the alternate segment, that is the major segment made by the same chord AB, for which we take a point on the circumference of the major segment. We call it R. We join the end points of the chord A and B to R. So we join AR, we join BR. And hence we find an angle now formed ARB. In fact, angle ARB is the angle subtended by the chord AB in the major segment at the point R. Angle ARB is the angle subtended by the chord AB at the point R in the major segment. These two angles are equal. Angle ABP is equal to angle ARP. Reason, angles in the alternate segment of a circle are equal. Reason, angles in the alternate segment, that is major and minor segment, alternate segment of a circle are equal. Please make a note of this. Please make a note of this. Just draw the figure again. Draw the figure again, children. Mark the angles. Give you 3 minutes time for this. Done, children?
Yes, ma'am. Yes, ma'am.
All right. Let me just do it again. The same thing. We just see the same thing again. Circle, chord. I'm taking the chord in the same place so that it's clear to you. The chord can be anywhere. The chord, endpoint, endpoint. Through any one endpoint, we take a tangent. We take a tangent, tangent. This is one of the angles. This is one of the angles between the chord and the tangent. So till the tangent here. This is an angle between the chord and the tangent. And this crosses the minor segment, the minor segment. Okay, so this is one angle. Now we'll find an angle in the major segment. You can take the point anywhere. You can take the point here also. Join. So this is a point on the circumference of the major segment. Join the ends of the chord to this point. And an angle is formed. Now this angle is subtended by the chord, the same chord in the major segment. Now this angle is equal to this angle. Now how does it work for any angle in the segment is because we know that angles in the same segment of a circle are equal. 9th standard. Angles in the same segment of a circle are equal. This angle is equal to this angle. Angles in the same segment of a circle are equal. So you can take another, if you take another point here like this, and you join the ends of the chord, this angle also will be equal to this angle. Because this angle is also subtended by the same chord at this point on the circumference of the major segment. So this angle is equal to this angle also. Because these two angles are equal, they are in the same segment of a circle last year. Angles in the same segment of a circle are equal. Now let's take it up the other way around, children. Circle, taking the same chord AB, and through this point B. This is the tangent. I think we call the tangent PQ. The tangent is PQ. Now let's talk about this angle, which is contained between the chord and the tangent. This angle, which crosses the major segment. See, this is the major segment of the circle. This is the major segment of the circle. Now this angle crosses the major segment of the circle. This angle crosses the major segment of the circle. This is an angle between the chord and the tangent. Chord, tangent, angle. See here, chord, tangent. This is an angle between the chord and the tangent. And it crosses the major segment. So leave the major segment. Take a point on the circumference of the minor segment. This is the minor segment. Take a point on the circumference of the minor segment. Join the ends of the chord. Join A to R, B to R. Join the ends of the chord to that point. And an angle is formed here. That is, this is the angle. Angle ARB. Angle ARB is the angle subtended by the chord AB at the point R in the minor segment. AB is the chord, R is the point in the minor segment. Join A to R, B to R, the ends of the chord. And you can see an angle here, angle ARB, which is subtended by the chord AB at the point R in the minor segment. Now these two angles are equal. Angle ARB or you can BQ. Angle ABQ is equal to angle ARB. ABQ is between the chord and the tangent. And ARB is the angle made by the chord in the alternate segment. ARB. The reason angles in the alternate segment of a circle are equal. Angles in the alternate segment of a circle are equal. Circle are equal. Yeah, please make a note of this, children. Is it over, children?
Yes, ma'am.
All right.
Yes, ma'am.
Let's answer this question. So here, SQL. No, sorry. One thing is. So another thing is. Sorry. Now, supposing you have to find this angle. You have to find this angle. You have to find this angle. And this angle is given. This angle is given. Supposing this angle is say 120 degrees. This angle is 120 degrees. This angle is 120 degrees. So how much will this be? This will be 60 degrees. So if this is 120, because the tangent is a straight line. So if this angle is this is between the this is a chord. This is a chord, and this is the tangent. And 120 degrees is the angle between the chord and the tangent. If this is 120, then this angle will be 60 degrees. This will be 60. Again, 60 degrees is the angle between the chord and the tangent. Chord and the tangent 60 degrees. And this, so this is this segment. In the alternate segment, you can see the angle here. This is the chord and it makes an angle here. It makes an angle here. In the alternate segment. See here, the chord makes this angle in the alternate segment. So if this is 60 degrees, this is 60 degrees, and angles in the alternate segment of a circle are equal. So if this is given, you can find this angle. Linear pair, you can find this angle, and now this angle is equal to this angle. Angles in the alternate segment of a circle are equal. Okay, so here SQL, this is 50 degrees. SRM, this is 60 degrees. Find QSR, you need to find this angle. You need to find this angle. Okay, just answer my questions, children. Yes, somebody wants to say something?
No, ma'am. I came to tell the answer.
Oh, please wait. What's okay? So given this 50 degrees, children, and this 60 degrees, you need to find the measure of QSR. Please answer my questions. What is the measure of this angle?
30 degrees.
Okay, class, what's the measure of angle ORM?
90 degrees.
Yeah, ORM is 90 degrees. Angle ORM is equal to 90 degrees because OR is a radius. Radius tangent perpendicular to. Yeah, ORM is 90 degrees. So if this full thing is 90 degrees, if ORM is 90 degrees and this one is 60, this remaining thing will be 30 degrees. So this one is 30. angle. This angle is 30 degrees. Similarly, what is the measure of angle OQL?
90 degrees.
OQL, see here, OQL. OQ is the radius, tangent. Radius, tangent. See here, OQ is a radius and this is a tangent. So this angle is 90 degrees. This full angle is 90. OQ is the radius, this is the tangent. So this from the radius to the tangent is 90 degrees. But this one is 50. So this portion will be 40. Correct? This is
Yes,
30,
ma'am.
this is 40. Okay, so this one is 30 degrees. This one is 40 degrees. Now join OS so that we can use the isosceles triangle property. Join OS so that we can use the isosceles triangle property. Now in this triangle, OR is equal to OS. So if this is 30, this is also 30. OR is equal to OS. OR is equal to OS. Radius of the same circle. 30 this is. And again in the other triangle, in this triangle, OQ is equal to OS. Radius of the same circle. So isosceles triangle property, if this is 40, this is 40. So the measure of QSR, is 40 plus 30, 70 degrees. 40 plus 30, 70 degrees. So first this one was given 50 degrees. So this one is 60 degrees. This was 60. 60. So this is 30. This one is 50. So this is 40. Then you need to join OS and use the isosceles triangle property. If this is 40, this is also 40 because isosceles triangle property. Similarly, this is 30, this is also 30. So QSR is equal to 40 plus 30, 70 degrees. So to find QSR, we are dividing it into two angles. We join OS and divide it into two angles. Understood, children?
Yes, ma'am.
That's what is explained here. That's what is explained here. You can take a screenshot. I've just now marked the angles X so that we can use the variables to, I've not, if I call them SRM or OSR, it's more difficult to understand. So I've just marked the angles X and Y. Same explanation, children. I've just used the letters X and Y. Okay, here I think I've done it in a different way. So, okay, I think I've done it in a different way here. Okay, I prepared this long back, I don't know. Okay, so now children, tell me that what's the measure of angle X, this X, children? How much is X?
30 degrees.
How much is this X then?
30 degrees.
How much is this?
40 degrees.
This one?
40.
Isosceles triangle property. So this angle is X plus Y, 30 plus 40, 70, that's all. I've worked in a different way here. I found this angle. And then I've used the property. That angle at the center is double the angle of the circumference. So I found this angle 140 degrees. And then using the property, angle at the center, angle subtended by an arc at the center. Center is double the angle. This angle is double the angle subtended by the same arc at any point on the remaining part of the circle. If this is 140 degrees, this is 70 degrees. 9th standard theorem. So in this working, I have found this angle 140 and then I found this. So this arc subtends this angle 140. The same arc subtends this angle. So this is 70. All right, let's move next one. Yeah, look at this one. Try this, children. What's the value of x? Now, can somebody tell me the measure of angle AOP? What is the measure of
60 degree, ma'am.
AOP?
60
How
degree.
much?
60 degree, ma'am.
Okay. 60 degrees, yes. Angle ABP. Angle ABP, or let me say angle AOP. Angle AOP is equal to twice angle ABP. AOP, ABP. Both of them are made by the same arc AP. AP subtends AOP at the center. AP, arc AP subtends AOP at the center. The same arc AP makes ABP on the circumference. Made by the same, see here, AOP is at the center. ABP is on the circumference. So AOP will be equal to 9th standard theorem. So AOP is equal to 2 into 30, 60 degrees. 60 degrees. So the measure of this angle is 60 degrees. What's the measure of angle? Yeah. What's the measure of angle? OPT, children?
90 degree.
OPT?
90 degree.
What's the measure of angle OPT? Reason?
90 degree.
Reason?
Because radius
Reason.
Radius is perpendicular to tangent.
Yeah, radius and tangent at the point of contact perpendicular to each other. See, this angle is 90 degrees. Now, why we found this is we are taking the triangle POT. We are taking this triangle POT. We are taking this triangle POT. This triangle POT. In this triangle, we found this angle is 60 degrees in this method. And then by the theorem, see here, this is the radius. OP is the radius. From the radius to the tangent, 90. See here, from the radius till the tangent, 90 degrees. So this angle is 90. So in this triangle, one angle is 90 degrees, another angle is 60. So by angle sum property, x is equal to 30 degrees. Because in triangle POT, one angle is 90, another angle is 60. So the third angle is 30 degrees. Take a screenshot, children. I'll give you some time to think about the answer, meaning to recall and understand the answer better. Just look at the screen. All right, let's go to the next one. Can I clear the slide, children?
Yes, ma'am.
Yes, ma'am.
Okay. Now, based on the doubt asked by a student. I want to ask you a question. Now, supposing we have, this is from volumes and surface areas. Supposing we have a toy or some solid like this in the shape of a, say, hemisphere surmounted by a cone. Or we have a toy or we have a solid in the shape of a hemisphere surmounted by a cone. Now, Arnav, if you run your hand over this toy, what will you feel? Will you feel the CSA of hemisphere and CSA of cone, or will you feel the TSA of hemisphere and TSA of cone? What can you, when you run your hand over this toy, what can you feel, or or if you have to paint this toy, what areas are available to be painted? Arnav, are you there?
TSA, ma'am. TSA.
Now, what is the difference between TSA and CSA? If the now in both these solids, cone and hemisphere, if the circular portion is also counted, see in with the, now in this cone, if the circular portion is accounted, it is TSA. If the circular portion is not accounted, it is CSA. Similarly, in a hemisphere, if the circular top is also accounted, then it is TSA. If this is not accounted, this is not there, this is missing, only this one, it is CSA, curved surface area. Now, Arnav, when you rub your hand over this hemisphere, can you touch the circular part of the hemisphere?
No, ma'am.
Okay, now ask the same question for the cone. When you rub your hand over the cone, that conical portion, can you touch the circular portion of the cone? Or is the circular portion of the cone visible?
If it is faced upside, then yes, ma'am. Otherwise, no.
How? No, in this toy. Now this toy is a hemisphere surmounted by a cone. It's a hemisphere and on top of the hemisphere is a cone surmounted by a cone. Oh, you're saying if the toy is like this, is it? Like, okay, like this. You're saying
Yes,
like
miss.
this?
Yes, ma'am.
Ah,
Yes, ma'am.
okay, the toy is like this. Can you touch the circular portion of the cone?
Yes, ma'am.
Now the hemisphere and the cone, they're stuck to each other. Their circular faces stuck to each other. Can you visualize that?
Yes, ma'am.
That is, you have a cone like this. You have a cone like this. You have another hemisphere. The circular mouth of the cone and the circular mouth of the hemisphere, they coincide. So you stick them like this. You put the hemisphere on top of the cone like this. When you do that, the two circular portions, they stick to each other, so they are not visible to you.
Yes, ma'am.
You have a cone. You have a cone. When you have only the cone, yeah, you can see the circular part of the cone. But if you have a hemisphere whose circular mouth is the same as the circular mouth of the cone, and you put the hemisphere on top of the cone like this, like in this. The two circles, the circular portion of the cone and the circular portion of the hemisphere, they stick to each other. They coincide.
Yes, ma'am.
So you cannot see. You can neither see the circular part of the cone nor the circular part of the hemisphere. Now, Arnav, you tell me where is your doubt? Why with TSA and CSA? It's just this. It's where, because it depends on the situation. It depends on the situation. Meaning, if you just imagine that you have to paint the solid which you have, where all you can run the brush. All that area has to be accounted.
Yes, sir.
This is how we have understood in class. Yeah. No. If it is TSA, you still stick to TSA. We have to understand why it is not TSA. Now, like this, you're saying both are the same. Whether you hold the toy like this or like this, both are the same.
Yes, ma'am.
Yes, Arnav. Now a little louder. I'm not able to get you. Yes, Arnav. Now tell me. Now you're trying to paint the. You're done with painting the CSA. You're done with painting the CSA. Now you want to paint the circular portion of the cone. Is it visible, or is it possible to run the brush over the circular part? Only if it is seen, you can do it.
Not seen, ma'am. Not possible.
Because the circular portions of the two objects
Covered.
are stuck to each other. Yeah, correct. They're covered. It's not that you can break the toy, paint it, and then put it back. It's not like that. It's a solid.
Okay, ma'am.
Yeah, so you can paint only the CSA of the cone. You want to paint the circular portion of the cone, but it's not visible. So that means you can paint only the CS. If you can paint the circular portion, then it is TSA. Otherwise, it is CSA. Because only that is visible. The same thing applies to the hemisphere. You want to paint, the CSA, this one, and you want to paint the circle. If you paint the circle also, then it is TSA. But no, they're stuck. The circular portions are stuck. You cannot see the circular, mouth of the hemisphere. You can see only this portion. So which means you can paint only the CSA of the hemisphere. Now tell me the total area to be painted, Arnav. What's the total area? What is the expression? What's the total area to be painted?
Ma'am,
It is
2 pi r square plus pi rl.
2 pi r square plus pi rl. Very good. 2 pi r square plus pi rl. What will be the total volume of this solid?
2 by 3 pi r cube plus 1 by 3 pi r square h.
Okay. Very good. All right, Arnav. Now, Arnav, answer this question. Now, there is a cylinder. There is a cylinder. Okay, a solid cylinder. What you do, you remove a cone. You remove a cone of the same radius and same height. That is, you take out a cone from the solid cylinder. You remove a cone of the same height as the cylinder and same radius as the cylinder. That is the radius of the cone, radius of the cylinder, both are the same. The height of the cone, the height of the cylinder, both are the same. So, Arnav, initially you had a solid cylinder. What you do is you remove a conical piece from the cylinder of the same radius and height as the cylinder. Now tell me, what is the area available to be painted? Just ask yourself these questions. What all you can see? Now lift the solid and see under. Can you see the circular, this circular base of the cylinder?
Yes, ma'am.
Is this intact? Is this intact?
No, ma'am, it's removed. It's there still with the cylinder.
Sorry, louder.
It's still there with the cylinder. It's there at the base.
With the cylinder. So you can, now can you paint the CSA of the cylinder?
Yes, ma'am.
So you have to add a 2 pi RH. Can you paint this portion of the cylinder?
No, ma'am.
No, because that's gone away with the cone. You want to paint, but it's hollow. You will just run the brush in the air. There is the circle, but there is no material to be painted there. Yes or no, Arnav?
Yes, ma'am.
Yeah, so this under this portion, here the material is there. You can paint this. You can paint this. But since you've hollowed out a cone, the top circle is gone away with the cone. So there is nothing here to be painted. So we can paint this bottom circle, which is under, when you lift the solid and see under, you can see a circle. So pi r square. Then the CSA of the cylinder you can paint. So 2 pi r h. Then you want to paint the top, but it's hollow. There's nothing there. So ignore that. But then if you see inside, you can see the CSA of the cone. Supposing this is made of wood, nothing should be brown in color. Everything should be like, say you're painting it red, it should be red in color. Everything should be red in color. Nothing should be of wood color. So you will paint this bottom red, pi r square. You will paint the CSA red, 2 pi r h. But you're not done. If you look inside the cylinder, you will see because you've hollowed out a cone, the CSA of the cone will be visible to you. So that also must be painted so that the entire solid is painted red. So what is the CSA of the cone? I don't know what's the CSA of
Pi RL.
pi RL. Are we done or do we have any more surface to be painted?
Done, ma'am, done.
Yeah. So like this, when we find area, we must keep adding all the surfaces that are available to be painted. See, the question may not be painted, but you imagine like that. Whenever it is area, just ask yourself the surfaces that are available to be painted. Wherever you can see the surface and that can be painted, all that should be accounted to find the area. So I can paint the bottom, so pi r square. I can paint the CSA that is intact, so that's 2 pi r h. Then if I look into, because the cone has come out, when I see inside, I can see the curved surface area of the cone. So I have to paint that also. Once I do painting all these three surfaces, I'm done. I'm done. Now the entire solid is red in color.
Okay, ma'am.
All later.
For me, I got confusion because in the question they asked, find the total surface area of the solid, and they were adding CSAs. That's why.
No. That's what it is. So if you can, we have discussed in the class that in the question, the term used will be total. What total surface area does not mean that we should use a total surface area formula. You must find the total area available in the solid you have with you. We should not apply the total surface area formula. What is a total? What is total meaning? What is the entire area available in the solid? That is what is to be found. We should not be misled by this word total. Total surface area is not, you should not directly pick the TSA formula and use it. So TSA can be, yeah, okay, yeah, thank you. So children, if you want to take a screenshot, just what we discussed, you can take a screenshot. Yeah. So in this figure, children, we have to find AQB. We have to find AQB. In this question, we have to find AQB. AQB. 1 minute. Yeah, this angle. We will have to find this angle. This angle. Okay, so let's find. So children, now let's try to use the alternate segment theorem. Can we see the chord BQ? Chord BQ. Yes, we can see the chord BQ. And this is the tangent. See, you can see the chord. You can see the chord here and the tangent segment here. Now, this is the angle between the chord and the tangent, 70 degrees. And this is the minor segment. This is the alternate segment, which is the major segment, Now, this chord, the same chord BQ. See, this is the point in the alternate segment or the major segment. Join BA and QA. It's already connected. I'm just telling you. This is the chord. This is the tangent. This is the angle between the chord and the tangent in the minor segment. This is the alternate segment. This is with respect to this chord, children. This is the alternate segment. This is the minor segment. This is the major segment. Now this chord BQ makes BAQ at the point A in the alternate segment. See here, BAQ. BQ is the chord. BAQ. See, you're getting the endpoints of the chord. BAQ. That is you. It's like you join BA and QA and you get the angle BAQ. So angles in the alternate segment of a circle are equal. So when this is 70 degrees, this is also 70 degrees. Angle BAQ is equal to 70 degrees because BQR is 70. Angles in the alternate segment of a circle are equal. So we got this is 70. Now already see this. You can see I've marked parallel lines. These two lines are parallel. You can see it's marked in the figure. So parallel line, transversal, parallel line. Or I think we don't have to even find that. We don't have to even find that. We have to find only this angle, right? So we got this is 70. If this is 70, see a parallel line, transversal, parallel line. Alternate angles are equal. So this is also 70. So now this angle will be, what do you call that? Sum of the angles on a straight line is equal to 180. So 70 plus if you call this x plus 70 is equal to 180. So x is equal to 40 degrees. X is equal to 40 degrees. This is 70. So this is 7. First step is this is 70. Angles in the alternate segment of a circle are equal. Next, parallel line, transversal, parallel line. Alternate angles are equal. So this is 70 degrees. This is 70. So this is also 70. Now 70 plus angle AQB plus 70 is equal to 180. So angle AQB is equal to 40 degrees. A screenshot, children. Parallel lines are marked here. Parallel line. Alternate angles are equal. Is it fine, children? Can we move on to the next one?
Yes,
ma'am.
Okay. See, don't get confused. Alternate angles are different. Angles in the alternate segments of a circle are equal. That's different. This is alternate segment of a circle are equal. This is alternate angles. Parallel line, transversal, alternate angles are equal. Right. Please find angle PQB. PQB. This angle. We need to find this. Yes, children. Tell me. Yes, this question is for you. Are we working on it, children?
Yes, ma'am.
All right, Priyadashini. Class, use the emoji. Raise your hand. Kirunesh, Priyadashini, Arnav, Shruti, Srinivasan, Priya, Muthuvel, Nivedita, Sudarshan, Akshara, Shravati, Shriya, Shivani, and Balaharish. Very good, children. Oh, almost like the regular attendees. Very good. I don't know if 5:45 will be convenient for all, but since the classes for the academic year 22-23 has begun, I have my new 8, 9, 10 batches. So this is the only time available for me. So that's why I didn't check with anybody. I just fixed it to 5:45 to 7:30. After that, I have another class.
X is equal to 32 degree.
Maybe some of them want to join. They are held up in school. Have you started your study holidays, children?
No, ma'am.
For Kamala Niketan, it's exam. ma'am.
Okay. They can leave you to study by yourself. How many exams? This is the third exam, is it? Shakti?
Yes, ma'am. Third exam day after tomorrow.
Okay. Okay. Yes, children. So coming back to this question,
32 degree, ma'am.
32, is it?
Yes, ma'am.
Yeah, tell me how you found out.
By the theorem, we can get PR.
Should use that, or you should have used the alternate segment theorem.
Yes, ma'am.
Yeah, tell me.
By that, we will get PRQ is equal to 58 degree, ma'am.
PRQ is 58. Very good.
After that, we can join O and P, ma'am.
O and P. Okay. No, without that. Okay, you have done like that, is it? Okay,
Yes,
that's
ma'am.
fine. But without that, you can find this angle, no PQB.
Yes, ma'am.
Okay, let me listen to you. Yeah. Okay, let's join OP. Yes, Shakti.
So that we can get OPR is equal to 58 degree.
Very good.
And we will get POR as
Children,
64
OP,
degree.
1 second, children. 1 second, Shakti. Yeah. So OP is equal to OR, radius. So this one is an isosceles triangle. OR is equal to OP. So this is 58 degrees. This is also 58 degrees. Correct. Then, Shakti.
And we will get POR as 64 degree, ma'am.
50, 50, 116, 64. Huh?
Yes, ma'am.
Yeah, correct. So, yeah, next.
And we can tell QOP as 116 degree again, ma'am. By that we can use isosceles property and we can find it.
Oh, you found this one using linear pair axiom, is it?
Yes, ma'am.
Okay, and then you again said OP is equal to OQ, and you found these two angles because they're equal. Like you
Yes.
found this one. You found
Yes.
this one which is 116. And again, these two angles are equal, and you found this.
Yes, ma'am.
You have just applied the theorem which we learned last year. No, see here. After this point, see, this is 58 given. All of you please see your screen. This is 58 given, okay. And then Shakti said by the alternate segment theorem, this is 58 degrees, that's fine. And then he used isosceles triangle property, this 58, okay. And then he found this one, 116 degrees, that's also fine. Now children, after this, angle POR is equal to twice of angle PQR, right? Angle made by the same arc. PR is the arc. PR makes POR at the center. The same arc makes PQR on the circumference. POR, PQR POR is at O by the arc PR. The same arc PR makes PQR on the circumference. 9th standard. Angle at the center is double the angle on the circumference. So like that, Shakti, you can say if this is 116, this has to be half of that. If this, but your answer is different, no?
No, ma'am. POR is 64 degree.
Oh my God, sorry. Sorry. Yeah. I wrote that angle straight. Okay, this is 58. So this is 58, alternate segment theorem. This is 58. 116, 180 minus 116. I didn't do that. Thank you. Yeah, this is 64. By angle some property, this is 64. So this one has to be 32 degrees. Half of 64, 32. Because POR, PQR. POR, PQR. See, it rhymes. Same arc PR makes POR at the center, PQR on the circumference. Center is more than circumference. So center is 64 means circumference will be half of that, 32. Angle subtended by an arc at the center is double the angle subtended by the same arc at any point on the remaining part of the circle. Okay, so like this you can do, that's right. What I was thinking is, children, what I was thinking is, Shakti, well tried, very good. Listen to this, children. This is 58 degrees. Alternate segment theorem, this is 58 degrees. Now you can see that QR is the diameter. So which angle is 90 degrees?
QPR.
QPR is 90 degrees because angle in a semicircle is a right angle, 9th standard. Angle in a semicircle is a right angle. So now this is 90, this is 58. So this angle will be 32 degrees. See, we have to find PQB, PQR. That's only PQB also. PQB is also same angle. I would like to repeat it, children. This angle is 58 is given. So this is between the chord PQ and the tangent in the minor segment. Alternate segment. This is the alternate segment. This is the tangent. This is the chord PQ. See here, P to R, Q to R. This is the angle in the alternate segment. So if this is 58, this is also 58. This is 90. Angle in a semicircle is a right angle. So by angle some property in this triangle, by angle some property, this is B is equal to 32 degrees. All right. I hope all of you understood. I'll show you the answer slide. Please read the answer slide. See, now you might think like, how do you know that you should find QPR first? First we plan and then only we start writing. Numericals, you cannot just start writing like that. First we plan, we work the entire answer in our mind and then we write out what we have planned. First you need to scribble in the rough column. You need to scribble, you need to find different angles and see which method is going to help you. Then you get one idea in your mind. That way, only then you start writing in some order. So it's basically a rough work and then a fair work. Otherwise, how will we know that we should find this angle and then all this? So we first work it rough and then we make this copy, fair copy. Okay, all that we just discussed. Take a screenshot, children. we've discussed in the class earlier. Yeah. If AOB is 100, find BAT. If AOB, if this angle is 100, find BAT. Yes, children, please find.
Ma'am, 50 degree.
50 degree,
yeah?
ma'am.
50. Yeah.
Yes, ma'am, 50.
Arnab, yes, tell me, Arnab, how do you work it?
Ma'am, it's given angle AOB is equal to 100.
Yeah.
And since AO and B are radii, so they both are equal.
Correct.
So angle AOB, so angle OAB plus angle OBA, I mean angle OAB plus is equal to angle OBA.
Correct. How much is this?
So 40 degrees.
40 degrees. Then Arnab, after that?
And ST is a tangent, so OAT is equal to 90 degree.
OAT, from radius to the tangent. OAT. See here? OA is the radius, AT is a tangent. So between that angle is 90 degrees. OA is the radius, this is the tangent. So this full thing is 90. How much is this?
40.
40. So
90
BAT
minus
is
40, 50.
90 minus 40, 50 degrees. Very good. Correct. Ninety minus 40, 50 degrees. You can also use the angle alternate segment theorem like this. See, like you can take a point. You know that BAT. You know that BAT is the angle between the chord and the tangent. BAT, what you have to find, BAT is the angle between the chord and the tangent. This angle is the angle between the chord and the tangent, BAT. So you would like to find the corresponding angle in the alternate segment. So take a point like this, join this point, let me call this P. So join AP and BP, join AP and BP. So you can see that AB is the chord and APB is the angle subtended by the chord in the major segment. This is 100. So this will be 50 degrees. Line standard theorem. Angle in the center, double the angle on the circumference. So now by alternate segment theorem, this is also 50 degrees. You can also do it like this. Take any point, call it P, join AP, join BP. This is 100. So this angle on the circumference will be 50 because it's made by the same arc AB. AOB, APB. So 150. Now this chord makes 50 degrees in the major segment. And this is the angle between the same chord and the tangent here in the alternate segment. So if this is 50, this is 50 degrees. Chord, tangent, 50 degrees. Same chord in the alternate segment, 50 degrees. Okay, I have worked it the way we just discussed in the class. How about this, children? QPT, this angle, QPT. is 60 degrees. Find PRQ. QPT is 60 degrees. Then how much is QPS, children? How much is QPS?
120 degrees, ma'am.
120. Now it's between this chord and this tangent in the major segment. This is the chord. This is the tangent in the major segment. The same chord subtends QRP in the minor segment. Or PQ, whatever this angle is, PRQ or QRP. So this is also 120 degrees. Here chord, tangent. This angle is 120. This is the major segment. This is the major segment. So with respect to this chord, this will be the minor segment. This is the minor segment. So the same chord in the minor segment, it makes PRQ. The same chord PQ. See here PR, QR. This angle. These two angles are equal. Angles in the alternate segment of a circle are equal. These two angles are equal. So if this is 120 degrees, this also will be 120 degrees. Because this is 60, that is 120. So we found QPS first and then alternate segment theorem. All right. Yes, children, find X. Now, children, what can you say about PQ and PR?
Tangents from external points are equal.
Yeah, the external point is P. PQ and PR are tangents from the same external point of the circle. They are equal. PQ is equal to PR. So that means in triangle PQR, this angle is equal to this angle, correct?
Yes, ma'am.
Yes, ma'am.
So what will be the measures of these angles?
75 degrees.
75 degrees each. 75 degrees because 180 minus 30 is 150. 150 by 2, 75 degrees. Now can we see parallel lines, mark? Parallel line, transversal, parallel line. So what will be the measure of this angle?
75 degrees.
75 degrees. And then again the alternate segment theorem, chord, tangent. Chord, tangent, 75. The same chord in the alternate segment makes this angle. This angle. So how much is this?
75 degrees.
75. Alternate segment theorem. So now in the triangle, by using angle sum property, this will be 30 degrees. This will be 30 degrees. These two sides are equal. 30 degrees. 180 minus 30 is 150. 150 by 2, 75, 75. Now, if this is 75 degrees, this is also 75. Angles in the alternate segment of a circle are equal with respect to the chord RQ. With respect to this chord RQ, if this is 75, this is also 75. Also, parallel line, transversal, parallel line. Alternate angles are equal. So if this is 75, this is 75. Alternate angles, parallel lines, transversal, alternate angles are equal. Now in this triangle, by using angle sum property, this angle is 30 degrees. Okay, children, I've done a different way. Let me not confuse you, because these I've worked it long back, so I'm not sure about. You can, no numericals, you can find different angles and find different things. So I'll just write out what I just explained. So you should first talk about these two sides equal and then find these angles 75, 75. Then you must say alternate angles are equal. This is 75. Alternate segment theorem, this is 75. And then this is 30 degrees by angle sum property. Yes, children, I've written it for you. All right. Can I close this file, children?
Yes, ma'am.
Yeah, you can try this. Take a screenshot. Take a picture of this one. I'll show you the answer also. You can try this one. Now, children, this result is very important. It's not of this question. It's not of this question. I'm just reminding you of this result. Right triangle, in circle, right triangle, in circle. Okay. Right triangle, in circle. All right, children. So let me call this A, B, C. Let's say this is called, because we know that normally the hypotenuse is called C. The legs are called A and B. The legs are called A and B. The legs are called A and B. So this full thing is A. This full thing is B. And the hypotenuse is C. The hypotenuse is C. Now you know how to prove that this one is a square. You know how to prove, that's what is important. You know how to prove that this one is a square. This is a radius. This is the radius. But since this is a square, this is also R, this is also R. Now the full thing is A and this is R. So how much? See, this much is R. Then what is this much? What is this part?
A minus R.
A minus
A
R.
minus R. A minus R. A minus R. If this one is A minus R, how much is this? Or what is this? That also is A minus R. Because tangents from an external point of the circle are equal. If this is A minus R, this is also A minus R. This full thing is B and this one is R. So this remaining portion will be B minus R. And if this is B minus R, this one is B minus R. This one from here to here is B minus R. From here to here is A minus R. Now A minus R plus B minus R is equal to C. A minus R plus B minus R is equal to C. So you get A plus B minus C is equal to 2R, or R is equal to A plus B minus C by 2. We have done this in the class, children. If you have attended all the classes regularly, you can see this in the chapter circles.
Yes, ma'am.
Thank you, Priyadarshini. So this result, see, whether this will come, we don't know, but it's important. This is a square. This one is a square. So R, this is R. This is R. The rest of it will be A minus R because the full thing is A. The side is A. So the rest of it, this one will be A minus R. But we know that tangents from an external point of the circle are equal. So this one also is A minus R. Similarly, this is R. Like this is R, the rest of it is A minus R. This is R, so the rest of it is B minus R because the full thing is B. And if this is B minus R, this one is B minus R. Tangents from an external point of the circle are equal. Now, A minus R plus B minus R is equal to C. A minus R plus B minus R is equal to C. A minus R plus B minus R is equal to the hypotenuse C. So when you work this, you get A plus B minus C. A plus B minus C is equal to 2R. Is equal to 2R. Or R is equal to A plus B minus C by 2. So where this question will be asked is, you may be asked to derive that result. Derive that result. R in radius is equal to A plus B minus C by 2. Derive this result. And the hypotenuse is C. So when you work this, you will get R is equal to A plus B minus C by 2. This result is important to find the in radius. In words, we say it is the sum of the legs minus hypotenuse by 2. A plus B, sum of the legs minus C minus hypotenuse by 2. Sum of the legs minus hypotenuse by 2 is the value of the in radius. So now tell me, what is the in radius? How much is the in radius? What's the value of R? Quickly work using the formula. R is equal to, work and tell me.
Ma'am, 5 centimeter. Ma'am.
One minute, sorry. Take these values. Yeah, take these values and tell me.
Ma'am, 4 centimeters. Ma'am.
4 centimeters. How do you do it? R is equal to
A
R
plus
is equal to A plus B minus C by 2.
yes,
Yeah,
ma'am.
what is A?
Ma'am, 24. Ma'am.
What is B?
10, ma'am.
And what is C?
26, ma'am.
How do you find 26?
Ma'am, by Pythagoras theorem.
Pythagoras theorem. C is the hypotenuse by 2. So it will be 34 minus 26. 8 by 2. 4 centimeters. So the length of the radius is 4 centimeters. Very good, Shakti. All right, children, let's understand this one and wind up the session for today. All right. Yeah. Let's just do this and wind up the session for today, as I told you. PRQ is 120 degrees. PRQ, this one. PRQ, this is 120 degrees. Now, children, if PRQ is 120, tell me how much is this angle? Recall this theorem. Circle, circle, tangents. This angle is equal to this angle. Please remember that. By the theorem, this angle is equal to this angle. If this full angle is 60 degrees, it's 30 here and it's 30 here. Similarly, this angle PRQ, see here, it's between the two tangents. See here, this one, PR, this one is 120. RP and RQ. RP and RQ are the tangents. RP and RQ are the tangents. RP and RQ are the tangents. So the angle between them is 120. And this is the line from the center. So this is 120 degrees. This one is 120 degrees. So this portion will be 60 degrees and this portion will be 60 degrees because equal angles are equally inclined to the line segment joining the center and the external point. If you do not know it in words, it's fine, but you know this result. I just showed you. This angle is equal to this angle. 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 So now this is 60 degrees. This is 60 degrees. Of course, this is also 60 degrees. This is also 60. Now we need to show that OR is equal to PR plus RQ. But PR and RQ are equal, right? PR and RQ
tangents.
are equal. Yeah, they're equal. So instead of showing PR plus RQ, can we just try to show that OR is equal to twice PR?
Yes, ma'am.
Yes, ma'am.
Because these two are equal. PR and RQ, they're tangents from the same external point of the circle. They're equal. Instead of showing that OR is equal to PR plus RQ, you can just show it as twice PR or twice RQ, whatever. Twice PR or twice RQ, any one of the two. Now, supposing we choose this OR, anything you can do, children. So, supposing we choose this OR is equal to twice PR. Where are the sides OR and PR? Where are the sides OR and PR? In which?
OPR, ma'am.
OR and PR. So we need to connect, we need to join this radius OP. We need to join this radius OP. So now we have contained the side. Now we need to prove that OR is equal to twice PR. So now we have contained OR and PR in this triangle OPR. In this triangle, why did we join OP? Because OR and PR, you know, they're just two line segments. You know, you couldn't get any triangle. So we joined OP so that OR and PR are now sides of triangle OPR. Now trigonometry comes to our, you know, rescue or help. So this is 60 degrees. This is 60 degrees. And radius tangent perpendicular, so this is 90 degrees. Now we need to use a suitable trigonometric ratio and connect OR and PR. Connect
Cos 60 equals.
OR and PR. Which is the hypotenuse?
OR, ma'am.
OR, ma'am.
OR is the hypotenuse. OR is the hypotenuse. And for 60 degrees, what is PR? Adjacent side or opposite side?
Adjacent side, ma'am.
Adjacent side. Because OP is the opposite side. OR is the hypotenuse. OR is the hypotenuse. Because it's opposite of the right angle. PR is the adjacent side. Okay, so cos 60 degrees is equal to adjacent PR by hypotenuse OR. Cos 60, the value of cos 60 is 1 by 2 is equal to PR by OR. So OR is equal to twice PR. Now you can split PR as OR is equal to, now PR means PR plus PR, PR plus PR. So that means PR plus RQ. 120 degrees must be split as 60 and 60 using the theorem. Then you must take, you can also join this and take this triangle. You can also join this, use the same idea in this triangle. This is the right angle. Radius, tangent, perpendicular to each other. This is the right angle. This is 60 degrees. So you should connect here OR and RQ. OR and RQ. You should connect OR and RQ. RQ. Same thing. Cos 60 degrees. You can use this triangle or this triangle. The same thing is explained here, children. Take a screenshot. ORP 60 is not given. We understand it's 60. ORP 60. Join OP to get the triangle. Then this is 90 degrees. This is 90 degrees. Then in the triangle OPR, which is the right triangle, we're using a trigonometric ratio, cos 60, which is adjacent by hypotenuse. Adjacent PR by hypotenuse OR. So that will give us this result. And we split it. And PR is nothing but RQ. Take a screenshot, children. All right, children. In today's session, we discussed some important aspects of this chapter, circles. Yeah, that's it for today's session, children. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you,
Thank
ma'am.
you, children.
Thank you, ma'am.
Thank you, children.